So we look at Earth and we can see that the continents look like they fit together. And we can see the rocks seem to match that concept. In the distant past, they were closer together. So what does this mean? Well, when continents are pulling apart, where they're rifting, you're going to have lots of earthquakes. And sure enough, we see lots of earthquakes right down the middle of the Atlantic Ocean. So it's not just South America going one way and Africa going the other way. All this ocean floor in here is going with those continents. So it's this entire region of the crust that's moving. Likewise, in North America, it's not just North America moving around. So it's not just North America, but it's North America and the ocean floor over here moving. Okay, and then this part of ocean floor going that way as Europe is going that way. But wait, we've got a problem here in that Africa is trying to slide a little bit that way, and they're crunching together right here. In fact, India and a big chunk of the Indian Ocean are heading this way to the north, but there's already something there in the way. And so likewise, South America and North America are heading to the west, but there's already ocean floor here. We're having to run over things. So this is a map of earthquakes. You can see earthquakes where you're cracking the surface and earthquakes where you're running things into one another. Asia's heading this way, but we already got the Pacific Ocean over here. So you're crunching into the Pacific Ocean along in there. And so you get all these different kinds of earthquakes mapping that. So at this point, we say it's plate tectonics, not just continental drift, because it's not just the continents themselves that are moving, but it's this entire plate that's moving. Okay, and that plate is a chunk of the surface of the Earth. And so even in North America, what we find is, interestingly enough, that the western part of the country is moving quite quickly that way. On the eastern part of the country, there's these where in the western part we have all these mountains along here. Why do we have all these mountains here? Well, because what's happening is we're trying to ride up over stuff that's already out here, and it's shoving the ground up, making mountains. And actually, California has to be its own weird little different thing, because California is really going that way, and so North America is running into California, so you now have more mountains back over here. Now, mountains, all these mountains are young mountains because we're constantly running into something there, and that's shoving the mountains up. Well, mountains don't just shove up gently. They do so in the form of earthquakes. So that would suggest this entire region of the country is going to have more earthquakes, and typically it does. Now, we got mountains on the eastern half of the country over here, but these are very old mountains. That's left over from when North America and Europe had run into each other in the past. That made those mountains, but they're not currently actively building the mountains. Instead, erosion is actually tearing them down. And so those mountains tend to be a lot smoother and more rounded than the Rocky Mountains, which are young, fresh mountains. Now, having said that, there's a couple other things that are going on here. The western part of North America is actually trying to move slightly faster than the eastern part of North America. It's almost as something really heavy we're weighing down the country over here. All right, so what's happening is that is trying to split the country right down the middle. Okay. In fact, it does split a little bit in there. Now, that means it's be a little bit lower in there. Now, if this were true, that would indicate there ought to be a really big river down this low spot in the middle. Well, guess what? There is. That's the Mississippi River. The Mississippi River Valley runs right down this thing that's trying to be a rift. Now, in the western part of the country, the rocks are all cracked up because we got one section going one way, another section going the other, grinding against each other all the time. We have constant earthquakes in there. But these earthquakes are mostly kind of small as things grind against each other. Every now and then something really big snaps, and you get a really massive earthquake along here. All along here you can get massive earthquakes. But in the middle of the country, the rocks are not all ground up. So that means that you have to build an enormous amount of pressure, an enormous amount of tension, and enormous amount of shear forces. Several different ways you break rocks. And you got to build enormous amounts of forces, and then the rocks snap in an extremely violent event. Some of the biggest earthquakes in the United States history have occurred right in the center of the country from this nascent sort of rift that's trying to form right there. Okay. So what drives all this? Well, remember we said the asthenosphere is kind of soft and fluid. It flows like a glacier. And so hot material comes up and then moves off to the side. Now, it's still rock moving along, and it's dragging on the rock that makes up the surface, and so it's pulling apart things. So if you had a continent here somewhere, and you had this going on underneath, you would crack the continent as different parts would separate. And then you'd have to fill in the low spot with some kind of different kind of rock that's coming from deeper. Well, that rock could be much more iron-rich, like basalt. Well, in fact, that's what we find. We find that the ocean floor is, in fact, mostly basalt. Okay, the continents are mostly granite family rocks. They're lighter. They float on top. And so that tends to explain some of these things. Where the continents are being pushed this way and the ocean is going this way, the lighter rocks will ride up over the heavier rocks. It would shove the heavier rocks down into the upper mantle, where what happens is they start breaking apart and melting. As they melt, then what happens is they've got gases in them, they got water in them, and so they start working their way up to the surface here, because now they're less dense than the surrounding rocks, and they burn these molten material rocks burn their way through the crust that's there, and they come out as volcanoes. So the western part of the United States actually has lots of volcanic activity as well. Where you shove the plates down, that is called subduction. And there's usually a trench located along there. And these are some of the deepest parts of the ocean. Some of the deepest parts of the Earth's crust are those trenches where you're shoving things down into the upper mantle. So back to earthquakes here. You can make maps of earthquakes. You can make maps of where the shallow earthquakes are, and where the deep earthquakes are, and where the really deep earthquakes are. So the shallow earthquakes are typically deep. They're typically things that are happening right up near the surface of the Earth. That's where you're crushing continents together. That's where you're rifting things apart. So that helps you measure where the rifts are, where you're pulling things apart, or where you're crunching things together here. Okay, so you're crunching things together. India's heading northwards. Eurasia's heading that way. You're crunching things up right in there. You know, and you're slamming a bunch of rocks together, and that pushes upwards to make actually pretty enormous mountains in there. So where you're rifting and pulling things apart, shallow earthquakes. The deep earthquakes tend to be where the subduction zones are. And you notice there's subduction zones all the way around the Pacific. Just inside of the subduction zones, you have volcanoes. So all around the Pacific, you have volcanoes and subduction zones, and that means earthquakes, because you're bending rock and shoving it down into the upper mantle, and it's breaking apart and so forth. Okay, so you have these deep sort of earthquakes. These are big earthquakes in many cases, so we call this the ring of fire. because of all the volcanoes and earthquakes that circle the Pacific. Some exceedingly deep earthquakes are also located along there, where you are got these subduction zones and you're shoving stuff way down into the mantle. And so that's again that's indicative here of this sort of activity we've been talking about. So recap right here: continents are moving this way, ocean floor is moving that way. You shove the ocean floor down. The ocean floor is mostly volcanic rock, basalt type rock, but it's been sitting there in the ocean floor, picking up sediments, picking up sedimentary rocks from top, just sitting in water, and so forth. And so it shoves down into the upper asthenosphere. It melts, works its way up, and eventually comes out in the form of lava. Okay, and volcanoes. Volcanoes are inland from the edge of the continent somewhat. So again, like in the United States, most of our volcanoes are near the west coast, but they're not right on the coast. They're inlands a little bit. Again, this is a graphic showing overall the direction of motion of most of the plates out there.